Welcome to the DIY Honda Garage channel. The Diagnostic Trouble Code, DTC P2182, indicates that the Engine Coolant Temperature, ECT, sensor 2 is out of range. This sensor plays a crucial role in regulating the engine's temperature, providing vital information to the Powertrain Control Module, PCM, about the coolant temperature. The PCM uses this data to optimize fuel injection, ignition timing, and other critical functions to ensure efficient engine performance. ECT sensor 2 is typically located near the engine's coolant outlet or cylinder head, making it pivotal in monitoring the temperature of the engine. A correct reading from the ECT sensor 2 is necessary for numerous vehicle functions, and a failure could lead to overheating or decreased fuel efficiency. The troubleshooting process must be thorough to accurately diagnose the underlying issue causing this fault. The ECT sensor 2 monitors the temperature of the engine coolant and transmits this information to the PCM. This data is crucial for the computer to manage engine functions effectively. The sensor's typical location is near the engine coolant outlet or cylinder head, where it can accurately gauge the temperature of the coolant as it exits the engine. A malfunction can trigger DTC P2182, indicating that the readings from sensor 2 are outside the expected range. When the temperature readings are inaccurate, it can lead to poor engine performance, affecting fuel injection and ignition timing, which can severely impact fuel economy. Hence, understanding the component's function and location is essential for a successful diagnosis. Several reasons could lead to DTC P2182 being triggered. A common cause is a faulty ECT sensor 2, which may provide wrong voltage readings due to internal circuitry issues. Additionally, poor connections at the ECT sensor or the PCM can disrupt the signal transmission, leading to out-of-range readings. Sometimes, the wiring itself could be shorted, affecting the voltage supply and making the sensor appear defective. It's vital to consider all these factors during the troubleshooting process. Proper understanding of these potential causes can guide technicians in effectively isolating the issue and implementing the necessary repairs. Each potential cause should be checked meticulously to ensure a complete and effective diagnostic process. When DTC P2182 is active, it may manifest in various symptoms. One of the most critical indicators is an overheating engine, as the sensor's failure prevents accurate regulation of the coolant temperature. This overheating can lead to severe engine damage if not addressed quickly. Furthermore, drivers may experience poor fuel economy, as the PCM struggles to adjust combustion parameters optimally without accurate temperature data. Erratic temperature gauge readings may also be noticeable on the dashboard, leading to driver confusion regarding the real-time state of the engine. Addressing these symptoms promptly is essential to prevent further complications, and they serve as essential clues during the diagnostic process. Ignoring these indicators can lead to more serious repair needs down the line. Begin the troubleshooting process by turning the vehicle to the on mode. This step ensures that all electrical components are powered, allowing for a thorough diagnostics check. Using the Honda Diagnostic System, HDS, check the voltage readings from ECT sensor 2. According to the diagnostic parameters, if the ECT sensor 2 voltage reads 0.14 volts or less, the current conditions match the failure threshold, confirming the issue. If the reading is above this threshold, it indicates that the current conditions do not demonstrate this failure at this moment, and you must proceed to further diagnostics. Therefore, this step is vital in determining the initial state of the sensor and directing the next actions based on the results obtained. In this step, confirm the voltage of ECT sensor 2 again, ensuring that it reads 4.99 volts or more. If it does, you can replicate the failure conditions. potentially indicating that the sensor is not functioning correctly under expected parameters. However, if the reading is below this threshold, it suggests that there might be an intermittent failure, meaning the system could be functioning normally at times. You should examine any connections or terminals associated with ECT sensor 2 and the PCM for looseness or corrosion. These inspections are essential because even minor connectivity issues can lead to erroneous voltage readings. If available data shows snapshots of before the failure occurred, attempt to reproduce the issue under the same circumstances to gather more clarity on the conditions causing the DTC. The next step involves turning the vehicle off and disconnecting the ECT sensor 2 2P connector. This action is necessary to isolate the sensor from the circuit and address potential faults without interference from the rest of the system. Once disconnected, turn the vehicle back to the on position and utilize the HDS to check the voltage at the ECT sensor 2 again. If the reading remains at or below the 0.14 volt threshold, this confirms that the failure is indeed related to the ECT sensor 2 itself. At this point, technicians can confidently move forward to explore other potential causes, knowing that the sensor is likely at fault. If the voltage exceeds the threshold, this suggests that another issue in the circuit may be present, necessitating further examination. For this step, turn the vehicle to the off mode once again and prepare to check for any shorted wires. Jump the SCS Service Check Short line using the HDS and wait for more than a minute to ensure the circuit's reset properly. Then, disconnect the PCM connector E, 80P, as it is important to isolate the wiring. Check continuity between the ECT sensor's connector, specifically female terminal number 2 and a body ground. If continuity exists, this indicates a short in the TW2 sensor/TW2 wire, suggesting that the wire between the PCM and ECT sensor 2 is compromised and causing erroneous readings. Addressing such shorts requires careful wiring repairs, ensuring all connections are secured to prevent recurrences of the same issue. Again, turn the vehicle to the off mode and disconnect the ECT sensor 2 2P connector. This time, you will use a jumper wire to connect the respective terminals A and B on the ECT sensor's connector. This procedure helps to simulate a functioning ECT sensor without relying on the sensor itself. Next, switch the vehicle to the on mode and employ the HDS to measure the voltage again at ECT sensor 2. If the readings show 4.99 volts or more, this indicates that ECT sensor 2 itself is faulty, necessitating a replacement. Conversely, if the readings do not match, this directs attention to potential wiring issues or PCM concerns, leading to the next steps in the troubleshooting process. At this stage, the vehicle should again be turned to the off mode, and the jumper wire should be removed from the ECT sensor 2 2P connector. This is important to restore normal conditions for testing. Power the vehicle back to the on position and measure the voltage at the designated test points within the ECT sensor 2 connector and a body ground. The expected result is approximately 5.0 volts at this junction. If you achieve this reading, the TW2 sensor/TW2 wiring line is confirmed to be functioning properly, allowing you to move to the next step in the troubleshooting process. Conversely, if the reading is outside this normal range, you should proceed to the following troubleshooting steps to further diagnose the issue. Conduct an open wire check on the SG6 line. Once again, start by turning the vehicle to the off mode and jumping the SCS line with the HDS for at least 1 minute. Following this, disconnect the PCM connector E80P. At this point, check for continuity between the designated test points, ECT sensor 2, 2P connector number 1, and PCM connector E number 45. This test will determine if an open exists in the SG6 line that could be causing the issue. If continuity is present, then the SG6 line is functioning properly, leading you to check any related service information for further guidelines or replace the PCM if necessary. If there's no continuity, then immediate attention is needed to repair the open in the wiring. For the final step of troubleshooting, you will conduct an open wire check on the TW2 sensor/TW2 line. Begin by turning the vehicle to the off mode, jumping the SCS line like previously, and disconnecting the PCM connector E80P once more. From here, check continuity between the test points of the ECT sensor 2 connector number 2 and PCM connector E number 54. This step is critical for determining whether any breaks in the wiring exist that could lead to the DTC P2182. Achieving continuity indicates that the wiring is intact, and you should proceed to check additional service information, while a lack of continuity would highlight an open in the TW2 sensor/TW2 wire, requiring immediate repair. After making any necessary repairs related to DTC P2182, it is vital to recheck the functionality of the ECT sensor 2. This confirmation ensures that the sensor is functioning correctly and is providing accurate readings to the PCM. Following this verification, clear the DTC from the Powertrain Control Module, PCM, using the HDS. This action resets the system and allows a fresh start for the vehicle's diagnostics. It's important to monitor for any reappearance of the code after operation, as this may indicate persisting issues within the circuit or sensor. A successful repair means the vehicle operates smoothly without triggering the DTC again, ensuring prolonged reliability. Continuous observations and recurrent checks are necessary to maintain the performance integrity of the repair. To prevent future occurrences of DTC P2182, it's essential to perform regular checks on all connectors and wiring related to the ECT sensor 2 and the PCM. Regular inspections can help identify early signs of wear or corrosion that may lead to connection issues. Additionally, ensure wiring integrity by checking for any frays or shorts that can disrupt the communication between the sensor and PCM. Keeping electrical connections clean and secure will substantially reduce the chances of faults. Consistent maintenance practices not only protect against DTCs, but also enhance the overall longevity of the vehicle's engine management system. Therefore, proactive measures are a worthwhile investment in the vehicle's continuous performance. In summary, DTC P2182 signals a critical issue with the ECT sensor 2, adversely affecting engine management functions. This trouble code is a reminder of the importance of the ECT sensor in vehicle operations, highlighting its role in maintaining optimal engine temperature and performance. By following the troubleshooting steps outlined, technicians can identify the root cause of the problem, whether it be a faulty sensor, poor connections, or wiring issues. Timely identification and rectification of the problems associated with this DTC can save the vehicle from potential overheating and inefficiencies in fuel consumption. Maintaining regular preventive measures further ensures that the vehicle operates at its best, preventing recurrence of similar issues in the future. Ultimately, understanding and effectively addressing DTC P2182 is essential for preserving the performance and longevity of the Honda Accord. Please like and subscribe to the channel. See you next time.